February 20th, 1943, north of Kasserine Pass, Tunisia. The official reports never fully captured what German tank commanders saw that morning in Tunisia. They noted losses, described terrain, and listed equipment destroyed, but they could not explain the uncanny way American Shermans moved. To the men inside their Panzer Rifles, the spectacle was unnerving. Across broken, sun-baked ground, 5 American tanks advanced not as individuals, but as if linked by some invisible thread. There were no hand signals raised through open hatches, no flags waved from cupolas, no motorcycle messengers darting between formations. Yet somehow each Sherman knew exactly where the others were and where they were going. They split, flanked, and converged on German positions with a precision that looked less like battlefield improvisation and more like choreography. To observers used to the halting rhythm of armored combat, the timing seemed almost supernatural, as though the Americans were guided by a single mind. Inside the German vehicles, the reality was grim. Commanders barked into throat microphones, their words vanishing into bursts of static. Drivers strained to hear muffled fragments over the roar of Maybach engines. 10-watt transmitters, the heart of the Fuji-5 radio system, were already at the edge of their range, barely carrying a kilometer when tanks were in motion. Dust, heat, and vibration made things worse. In practice, much of the platoon could hear only garbled noise. The limitations went deeper. Most German tanks carried only receivers, not transmitters. Crews could listen to orders from the lead vehicle, but they could not reply. If ambushed, immobilized, or spotting enemy armor, they had no way to report their situation. At best, they could fire a flare or hope a runner might survive the sprint back. German tactics were therefore brittle, resting on fragile chains of command. Destroy the lead tank, and the rest were left without guidance. An entire platoon could be reduced to silence in seconds. The Americans, by contrast, fought under a different philosophy, one rooted in communication. Every Sherman carried the SCR 508 frequency-modulated radio, a design that looked unremarkable in diagrams but was revolutionary in practice. Crystal-controlled channels locked frequencies in place, eliminating the drift that plagued earlier sets. At 25 watts, its transmitter reached far beyond German equipment, pushing clear signals across several kilometers, even in difficult terrain. The difference was immediately audible. German crews were used to voices swallowed by static, each engine ignition or artillery burst crackling through their receivers. American crews heard clarity. Commands cut through the mechanical chaos. Platoon leaders relaying bearing changes, gunners confirming targets, drivers adjusting speed in real time. Orders came in plain language rather than prearranged codes, because the sets were reliable enough to support natural conversation. To the Wehrmacht, this invisible capability was a weapon they did not even realize existed. Historians often emphasize armor thickness or gun caliber when comparing tanks. But on the battlefield, the more decisive advantage was often the radio waves tying American crews into a living network. Where German tanks fought as scattered individuals, Shermans fought as coordinated packs. The story of that advantage began long before North Africa. On July 22, 1941, the U.S. Army officially standardized 3 radio sets, SCR 508, 528, and 538, for all medium tanks. The project had been handed to Galvin Manufacturing, a Chicago-based company that would later adopt the name Motorola. 2 men stood behind the breakthrough: Daniel E. Noble, a visionary radio engineer, and Henryk Magnuski, a Polish immigrant with deep knowledge of FM technology. Their task was daunting. Radios had always been fragile instruments, housed in wooden cabinets in laboratories or offices. Now they had to endure the pounding vibration of tank tracks, the heat of desert campaigns, the shock of nearby explosions, and the constant interference of powerful engines. What they produced was nothing short of remarkable. The finished SCR-508 set weighed 181 pounds, substantial but manageable, and it came as a complete package. A BC-604 transmitter paired with two BC-603 receivers. The layout allowed tank commanders to monitor two networks at once, an enormous tactical leap. A company commander could keep one ear on higher-level orders while simultaneously managing his own platoon. No longer did information have to be passed down step by step. It flowed directly across the formation. The crew intercom system, the BC-606, was equally important. Before it, tank crews shouted themselves hoarse inside cramped, noisy hulls. With throat microphones strapped around their necks and padded noise-canceling headsets over their ears, American crews could speak in normal tones, even under fire. Every man in the vehicle, from commander to driver to gunner, was tied together by a wired network that kept confusion at bay. The technical sophistication ran deeper still. Unlike German radios, which operated on amplitude modulation, AM, the American sets used frequency modulation, FM. The difference was more than academic. AM systems were vulnerable to interference, the spark of an engine, the crack of gunfire. Even lightning could blur or overwhelm the signal. FM filtered such noise almost completely, producing clean voice transmission where AM delivered only hiss and distortion. For tank warfare, where the environment was a cacophony of mechanical and explosive energy, FM was a revolution. Another subtle but crucial innovation was the dynamotor power supply. German radios often pulled power directly from the vehicle's systems, introducing hum, buzz, and electrical spikes into transmissions. The SCR-508's dynamotor smoothed these fluctuations, ensuring the voice on the other end stayed sharp. To American crews, this meant fewer misunderstandings and faster reactions. To German crews, fighting against such clarity while trapped in a fog of static, it meant facing an enemy who always seemed one step ahead. The true significance of these systems revealed itself in combat. American platoons could shift formations on the fly, warn each other of ambushes, and concentrate fire almost instantly. When one tank spotted an enemy, all knew within seconds. When a commander fell, another vehicle seamlessly took over. To German soldiers peering through periscopes, it seemed uncanny. Shermans always arrived where they were least wanted, moving as though guided by a single will. In truth, that will was not supernatural at all. It was 181 pounds of steel, glass, and circuitry bolted into every Sherman. It was Daniel Noble's vision and Henrik Magnuski's engineering. It was the insistence of an army that communication mattered as much as armor. And it was the invisible weapon that turned an adequate tank into part of a networked force, reshaping the battlefields of the Second World War. Operation Torch, November 1942. The beaches of North Africa were a chaotic blend of smoke, confusion, and hurried landings. American troops, many of them untested in battle, pushed inland against Vichy French and German opposition. For the tank crews of the 1st Armored Division, it was a trial by fire. Their Shermans rolled off landing craft into deep sand and scrubland, quickly dispersing across an area that stretched nearly 50 miles. Under normal conditions, such a spread should have meant disaster. Without coordination, isolated platoons could be cut apart piecemeal by German counterattacks. Units that had never trained together spoke as if they had fought side by side for years. Tank commanders checked in across the desert, giving their positions and requesting support. Within minutes, artillery was called down with uncanny accuracy, guided by tanks that served as forward observers. When enemy ambushes unfolded, warning spread instantly through the net, and Shermans shifted their maneuvers as if choreographed. To German and French observers, the effect was startling. They expected inexperienced Americans to stumble, to blunder forward blindly, to be cut apart by the sharper tactics of the Axis. Instead, the Shermans moved like a single coordinated machine. The secret lay not in training or doctrine, but in the FM radios humming inside every turret. By comparison, the Africa Corps remained shackled to rigid command structures. A typical 5-tank German platoon might have one, perhaps two, vehicles equipped with transmitters. The rest carried receivers only. Orders flowed one way, from the commander outward. Subordinates could acknowledge only by their actions, never their voices. In the heat of combat, this created a dangerous brittleness. If the lead tank was destroyed or its radio damaged, the entire formation was left without guidance. A platoon might continue forward blindly or sit motionless in confusion, its men cut off from each other, even when separated by only a few hundred meters. American units had no such weakness. Any Sherman could assume command. Any crewman with a microphone could be heard across the company. The battlefield became flexible, alive. For the first time in armored warfare, communication was not a privilege, but a universal capability. Italy, 1943. The war moved north into the mountains of Sicily and the Italian mainland. Here, radio performance faced its harshest test yet. In the deserts of North Africa, radio waves had swept across open plains with relative ease. In Italy, ridgelines, forests, and stone villages blocked and scattered signals. For amplitude-modulated German sets, this terrain was crippling. Multipath interference, where signals bounced and overlapped, turned voices into incomprehensible noise. Tanks separated by little more than a ridge or a bend in the road were effectively mute. The American SCR-508, by contrast, thrived. Frequency modulation shrugged off interference that crippled AM systems. Reports from Italy recorded Shermans maintaining clear voice links even when operating on opposite sides of ridges. Platoons scattered by terrain fought as if still side by side. Tankers described communication at distances that German equipment could never achieve, and they did so routinely as though it were nothing remarkable. This capability shaped tactics. American armor could advance confidently into twisting valleys, knowing that calls for help would carry through. Artillery could be summoned almost instantly, even in rugged terrain. German commanders, forced to rely on rigid pre-battle plans, often found themselves unable to adapt once combat began. American crews, bound together by FM clarity, adjusted minute by minute. Normandy, June 6, 1944. The invasion of France brought another stage in the evolution of communication. On the morning of D-Day, Sherman tanks rolled off landing craft under heavy fire. Their radios immediately proved invaluable. Within minutes of touching sand, tank crews linked to offshore naval vessels. Requests for naval gunfire thundered back at German defenses, smashing strong points that might otherwise have halted the landings. Once inland, the SCR-508 kept the assault coordinated, preventing scattered units from dissolving into chaos amid the hedgerows and villages of Normandy. Yet even here, the Americans discovered a weakness. Infantry units carried SCR-300 walkie-talkies, compact FM sets designed for foot soldiers. But those sets operated on higher frequencies, between 40 and 48 MHz, while the Shermans spoke on lower frequencies, between 20 and 27 MHz. The result was silence between tanks and the very infantry fighting beside them. This disconnect had lethal consequences. German Panzerfaust and Panzerschreck teams lurked in the bocage, waiting at close range. Infantry spotted them first, but had no way to warn the tanks directly. Too often, a Sherman blundered forward, blind to the danger, and was engulfed in fire before its crew could react. The bocage problem and the solution. The Americans, however, adapted quickly. By July 1944, engineers and field units devised a simple yet ingenious fix. Steel brackets were welded to the rear of Sherman hulls, each fitted with a field telephone. Now, infantrymen could run to the back of a tank, lift the handset, and speak directly with the crew inside. A private on the ground could warn of a Panzerfaust team, request suppressive fire, or coordinate movement in real time. This change transformed cooperation. No longer were tankers and infantry isolated by incompatible radios. They became a single integrated fighting force. Infantry gained a shield of steel they could direct. Tank crews gained eyes and ears on the ground. By the launch of Operation Cobra in late July 1944, the system was fully in place. When American forces broke out of the Normandy hedgerows, tanks and infantry advanced as one. German defenses, already strained, collapsed under the assault. What had begun as a vulnerability had been turned into another American advantage, further widening the gap in battlefield coordination. In every stage, Torch, Italy, Normandy, Cobra, the pattern repeated. American forces learned, adapted, and expanded the role of communication, while German forces remained constrained by outdated equipment and rigid doctrine. Radios were not merely tools. They were weapons, as decisive as guns and armor. The voice carried over static, binding men together, proved stronger than steel alone. July 1944. When the breakout from Normandy finally came, it was not a trickle, but a flood. Over 200 Shermans of the U.S. 2nd Armored Division surged forward across the battered hedgerow country, moving as if controlled by a single brain. German defenders, veterans of Panzer Lehr, one of the Wehrmacht's most elite armored divisions, watched in disbelief as the American advance unfolded. The Shermans didn't lurch forward blindly. They didn't hesitate, halt, or wait for messengers. Instead, they flowed across the battlefield like water, shifting direction in unison. A German machine gun nest flared to life, and within moments, artillery shells rained down on its position, summoned by a single radio call from a Sherman that had spotted the danger. A gap appeared miles away, and within minutes, other Shermans were redirected to exploit it. On paper, German tanks outclassed the Sherman. The Tiger and Panther carried thicker armor and more powerful guns. In head-to-head duels, they were fearsome opponents. But battles were not fought on paper. In reality, those German machines fought as isolated gladiators, each one relying on the eyes of its crew alone. The Shermans fought as a network. Each one was a sensor, a node, a relay point in a living system that magnified their power far beyond the specifications written in a factory manual. German intelligence officers noticed the uncanny coordination but drew the wrong conclusions. Reports credited American rigid discipline and high levels of training. They assumed that the enemy's synchronization was born of drilled routine. Few suspected the truth, that the secret weapon was technological, not doctrinal. German commanders continued to believe that destroying command tanks, easily recognized by their multiple antennae, would throw American formations into disarray. What they never understood was that in a Sherman formation, every tank was a command tank. American industry. This miracle of coordination was not born on the battlefield alone. It was the product of American industry operating on a scale the Axis could scarcely match. In Chicago, Motorola's sprawling plant poured out SCR 508 sets with assembly line efficiency. More than 50,000 were built during the war, enough to outfit every one of the 49,324 Shermans produced, with thousands left over for other vehicles. Each set was an engineering marvel, containing 2,748 precision components, resistors, capacitors, vacuum tubes, crystal oscillators, all designed to endure the brutal shocks and vibrations of tank combat. Technicians tested them against heat, dust, and the relentless pounding of tracks on hard ground. The result was a piece of equipment as rugged as the tank itself, a radio that could survive not just the laboratory, but the battlefield. German production paled in comparison. Fewer than 6,000 FUG-5 transceivers were manufactured during the entire war, to be spread across more than 12,000 tanks. The math was cruel. At best, only 1 in 5 German tanks could transmit. The rest were reduced to silence, able only to listen, if interference and battlefield chaos allowed even that. Where American industry guaranteed every Sherman a voice, German industry left most of its armored force mute. September 1944. The value of that difference became clear at Aricourt. The 4th Armored Division, thinly spread across the French countryside, faced wave after wave of German Panthers. On paper, the Americans should have been swept aside. The Panther outgunned and out-armored the Sherman, and the Germans enjoyed local superiority in numbers. But once again, radios changed everything. As Panthers probed forward through morning fog, American scouts relayed their positions instantly. Shermans coordinated ambushes, calling in artillery within minutes and directing tank destroyers to ideal firing angles. Crews shouted bearings over intercoms. Commanders broadcast target grids over the net, and entire companies shifted to counter threats before the Panthers even realized they had been spotted. The results were devastating. By the end of the battle, U.S. forces had destroyed 281 German armored vehicles while losing only 41 Shermans. The numbers stunned German commanders. How could inferior tanks achieve such lopsided results? The answer, as ever, was that the Shermans were never truly alone. Each one was linked to dozens of others, and through them to artillery, air support, and higher command. The Panthers, blind and isolated, fought as individuals and died as individuals. March 1945. By the war's final months, American radios were shaping entire campaigns. When U.S. forces unexpectedly found the Ludendorff Bridge at Remagen still standing, a potential gateway into the heart of Germany, radio reports went out immediately. Within minutes, headquarters was aware. Within an hour, entire divisions were shifting to exploit the opening. German defenders scrambled, but their telephone lines had been cut by air raids, their radios too few and too fragile. They could not coordinate a timely response. By the time orders filtered down, American forces were already across the Rhine. For American crews, radios meant something more than efficiency. They meant security. Even when a tank was separated or advancing into dangerous ground, its crew knew they were never entirely alone. A voice was always a button away. Reinforcements, artillery, or simply another tank commander checking in could be summoned in seconds. The psychological comfort of connection was enormous. For German crews, the opposite was true. Isolation was constant. Tank commanders fought blind, knowing that if their leader fell, silence would follow. Battles felt less like orchestrated maneuvers and more like chaos, each vehicle fighting tank by tank without the support of its comrades. Otto Carius, one of Germany's most skilled and respected tank commanders, described the frustration in his memoir, Tigers in the Mud. Even he, a master of his trade, recognized the crushing disadvantage of operating in near silence against an enemy bound together by constant communication. When the war ended, U.S. intelligence officers carefully examined captured German radios. Their verdict was damning. German tank communications were judged to be 5 years behind American standards. The Soviets, given access to the same equipment, drew the same conclusion. They ignored the German models entirely, instead copying the American FM approach for their post-war armored forces. The lesson was clear. In modern war, connection outweighed armor. Firepower meant little if it could not be directed, concentrated, and coordinated. Radios had proven themselves to be not mere accessories, but central weapons of war. At Germany's surrender, Field Marshal Wilhelm Keitel supposedly admitted as much. "We knew how to build better tanks," he is reported to have said, "but you knew how to make them work together." Whether he truly spoke those words or not, the statement captured the reality of the conflict. The United States had not simply built nearly 50,000 Shermans, it had built nearly 50,000 nodes in the world's first armored battlefield network. From Tunisia to Normandy, from Aracourt to the Rhine, German crews discovered the truth too late. The Americans were not fielding tanks, they were fielding a connected force. And in the end, that made all the difference. It was not the 75mm gun or the armor plating that made the Sherman decisive. It was the 181 pounds of electronics inside. The SCR-508 turned a merely adequate tank into part of a greater whole, a machine that fought as a member of a living system. And it proved a principle that still defines combat today. The connected defeat the isolated. The network triumphs over the platform. Communication is survival.